in that on Friday, the only thing you were able to take the derivative of was sum and differences. If they gave you the product of two things together on Friday, you would have had to just FOIL it all out and then take the derivative using the power rule. But there's actually a rule called the product rule. How often do you use the word moreover besides when you're writing a rule for calculus class? Moreover. You use it with. Never use the word moreover, I don't think. When you write a paper for English. I always say like, in conclusion. Therefore, I use therefore a lot.
I use overall after I see it.
I use therefore in my last essay and this is also because I don't like essays, so.
I think I use therefore because it's in math a lot.
I don't know what I'm supposed to use, so.
I didn't do it either.
It's fine, there is.
I just realized what I was doing. I was on lesson 3-1, not 3-3. That's why I had it on 3.
So you have it now.
Yes.
Is that for just calculus?
This is just calculus first semester.
Okay. First semester?
Yes. And it has all my notes and my homework.
And there's always room for the work, and you have to get to the
Well, I have extra room, but I don't like these. My AP bio binder from last year was like. All right, so if you have the product of two functions that are differentiable, obviously we have to say that, because if they're not differentiable to begin with, then we can't use this. But if you take the derivative of their product, here's the rule. It looks scary, it's not that bad. The derivative of f of x times g of x you're going to take the derivative of the first function, so f prime of x times the second function plus the derivative of the second function times the first function. The derivative of the first times second plus the derivative of the second times the first. And you can really expand this to as many functions as you want. I'm only going to go one more step. But what if it was the product of 3 functions? Instead of having to multiply it all out, you can just do the same process. You take the derivative of the first one times the other 2, plus the derivative of the second one times the first and the last. What if it's 3 functions? I didn't put the x in this time, but put the x's in if you want. I thought it looked better without the x's.
Wait, what is the H?
It's just another function, right? Like f and g, f times g times h. Those are just 3 functions.
What do we put the X after the foreign sign?
I'm not answering that question. Look at the one above it.
Is it okay, like, if we put, like, for each function, like, it would make you more comfortable to put the derivative on front?
It would. So like you don't like see like the way this one is.
Yeah.
Totally fine. I tend to always just go in order, and so I tend to do it more this way than the way the book writes this one. But right, like just showing you that you take the derivative of each function times the other functions and you add them all together. It doesn't matter what order you do this in. Multiplication is commutative. So Sarah said she'd rather write g prime times f times h and then h prime times f times g. You're going to get the same answer. It's just whichever way you feel more comfortable with. And really, you could do this with as many functions as you want. I don't think you really ever see anything more than 3 functions, but it'd just still be this. This is the easy way. Let's practice some. It was a nod. All right, so notice the directions here say differentiate and find f prime of 0. I want to point out why the product rule is a necessity when dealing with functions. If we didn't have the product rule, the first step you'd have to do here is work all that out, distribute all that. It's possible to do, but it's a whole lot of work, and there's a lot of room for error messing up negative signs. I have to say, there's still lots of people messing up negative signs when they're foiling out stuff like a plus h squared. So notice we have two steps here. Step one is we just want the derivative. We want to differentiate, and then we're going to do the second part. But I'm going to practice the product rule here. So I'm going to do f prime of x. Again, I want you writing that. What do you mean?
3 squared minus 3.
So I'm going to take the derivative of the first, which is 3x squared minus 3, times the second, so I'm not changing it at all, 2x squared plus 3x plus 5. So I'm not there yet. Like, the first part of the product rule is you take the derivative of the first times the second, plus, then you take the derivative of the second one, right? The product rule will never have you, like, you will never just go through and take the derivative of everything, and let me tell you, people will do that on the test. It's a bad thing to do. The derivative of the first times the second plus the derivative of the second times the first. So what would the derivative of the second one be here? Times. Oh man, we still have kind of a lot of work to do to simplify this, huh? All right, let's go. So I'm just going to multiply, right? Everything in the first and zero. Well, I want you to simplify it first.
So I can plug in 0 like I'm on flow.
No, it says differentiate. Like, I want you to, if it says find the derivative, I want to know what the simplified derivative is. And then we're going to find it.
Second part which
We can simplify. It's good practice. We've been making little algebra mistakes that we should be practicing. It's not that bad. We're just multiplying. 6x to the fourth plus 9x cubed plus 15x squared minus 6x squared minus 9x minus 15 plus 4x to the fourth minus 12x squared plus 3x cubed minus 9x.
What if instead of the 4x plus 3 times x cubed minus 3x we put x cubed minus 3x times 4x plus 3?
You still should get those exact same numbers there, right? So like terms here, I think I have 6x to the fourth plus 4x to the fourth is 10x to the fourth. 9x cubed plus 3x cubed is 12x cubed. 15x squared minus 6x squared minus 12x squared. So it's going to be 15 minus 18, negative 3x squared. Negative 9x and negative 9x is negative 18x minus 15.
How easy that was.
It really was easy, JD.
How did you multiply that first line? Why did you just do
This times this, and this times this, and this times this, and then this times this, and this times this, and this times this. Yeah, like you take everything in the first times everything in the second, which is exactly what foiling is. The reason I don't like to say we're foiling very much because if it's not two binomials, like the first part here, you have to know to just distribute everything in the first times everything in the second.
Well, then why wasn't that negative 15 our last one?
It was. This was my last one for the first one.
Oh, you just started writing stuff.
and then that's the second one. Like I did it all at once because it's one big addition problem, right? Sure. That's the derivative. Now it says find f prime of 0, which I feel like is still easier to do now than up there because there was still a whole lot of simplifying to do when you plug 0 in. I can just tell right now what happens when I plug 0 in for x. 0, 0, 0, 0, minus 15. Which means at 0 of this graph, the slope would be negative 15. That wasn't bad. That's algebra. That's good, fun algebra. I gotta even make up the rest of this. I have. Well, I have the quotient rule, but I feel like we're going to go to get into the quotient rule all today.
I need one more. I know that there's some kind of it.
No, I'm still there.
Being sarcastic.
Alright, let's see. You're going to do another one. Find the derivative. So differentiate. Yes. If y equals 2x squared plus 3 times x to the 4th minus 7. I was not yelling at you for this here. So how about when you get done, on your boards underneath, write your final answer on your board. Hold up.
Hey, we're interactive.
That's the right answer.
No, that wasn't actually you. I knew you'd be upset about it.
No, but you're going to be taking an AP test without a calculator. You know?
Well, that's a while away.
We can do it.
Yeah. Oh my gosh. Yeah.
Well, I gotta work mine out. We all have different answers. Oh,
I have that.
I do. Okay. Hold on, don't erase anything. Okay, good, we did it right.
World defenses. What do you have?
See, you're erasing things when I want to see it.
Oh, I forgot. We're supposed to write y prime equals there because now it's right.
Wait, why did you just look at me and just do that? Was that just your answer? So let's check here. We definitely have some wrong answers. Is this right? Take the derivative of the first. Yes, what's the derivative of the first?
Oh, I know what it is. 4x plus.
Just 4x times the second, which is x to the 4th minus 7. Yes? Plus. second, which would be 4x cubed, times the second, which is times the first, which is 2x squared plus 3. Every time you should have two derivatives and two of the original functions when you're doing this, right? You can't just take the derivative of this times the derivative of this. And then work it out. So you get 4x to the 5th minus 28x plus 8x to the 5th plus 12x cubed. So you have one set of like terms. 4x to the 5th plus 8x to the 5th is 12x to the 5th plus 12x to the 3rd minus 28x. Checking everyone's. So I don't want to be like, you're right, you're wrong. You're right, you're wrong. I feel like that's mean.
Well, it makes us look like we're not positioned.
All right.
Good man.
So we're going to break this up into 2 days since North Pride day, and I was worried about doing all this at once. So today you're only going to do the product rule. You're not going to do the quotient rule.
Oh,
That's tomorrow. I have a song to go with the quotient rule, though. That's exciting.
I'm
Maybe.
gonna assume the question rule is you subtract.
It's a little more complicated than that. I'll just show you. It's the derivative of the first times the second minus the derivative of the second times the first, all divided by the denominator squared, or all divided by the. I'm getting it. Settle down. So here we got to figure out what you can do. You can't do all this. We're going to do this in 2 days, so you can do it all in one. But you're going to do 13. And on 13, there's 2 parts. It says do the product rule and then just FOIL it out and then do it to show that you get the same answer. So it's like a 2-for-1 problem. 15 and 16. Because it's a quotient rule. Most of these are quotient rule. Or a combination of quotient rule and product rule. It's the same problem. Isn't that exciting? 40. I think that's all you can do. You'll have 4 homework problems. Which means tomorrow you're going to do the rest of it. So I would just do these 4, and then tomorrow, like, this is all day 2, and we're just going to kind of continue that tomorrow. Okay?
So let's do the product rule first. Well, this is like, multiplying factors and just pulling out like
Yeah.
calculus.
Like if you didn't have the product rule, the only way you could do that derivative would be to multiply it out and then do it like you did on Friday. So they want you to FOIL it out first, then take the derivative and show that you get the same. Here, go to your phone and pick it up. You know that? What answer?